In this video, I wanted to make an example problem that is difficult for many students, where it asks you to calculate the area of the shaded region, and then it gives you a figure where it's basically two different areas that you need to subtract. In this case, the drawing, which I haven't done a great job of, I apologize, it appears to be a larger semicircle, but part of it has been removed, and that part that's unshaded is another semicircle. So we need to assume we're dealing with semicircles, and let's talk about the two areas under discussion. First, anytime we have an area of a circle, we should remember that that formula is area equals pi, approximately 3.14, times our radius r squared. Now, what I notice here is that in reality, I have a larger circle on the outside here that technically is being cut in half. I have this semicircle here. So for the semicircle, we're really going to take half of this area. So to get the area of this larger semicircle, this is for the larger one, we're going to take that answer, and whatever we get, we're going to cut it in half, or divide it by 2, okay? So the area of a circle is pi r squared, but it's half of the full circle, the full green circle. So we're really just going to be dealing with half of that answer. So let's go ahead and see, without calculating in our calculators yet, what this would be. The area of that larger semicircle would be pi times the radius squared cut in half. So what is our radius that's getting squared? And then we end up cutting the whole thing in half. Okay, let's think about it. The radius here we're given for the entire large green semicircle, it has a diameter of 3 inches. So what would its radius have been? That's right, half of 3 inches. Half of 3 inches is 1.5 inches. So we can put our 1.5 inches here. We're talking about from here to here. The radius of this circle is 1.5. The radius of this larger circle. So 1.5 inches. So if I put 1.5 inches here, and I'm going to go to my handy dandy calculator, and I'm going to type in 1.5 times 1.5. That's what it means to square something. So when I type in 1.5 times 1.5, what am I getting? 1.5 times 1.5 gives me 2.25. So 2.25. Notice inches times inches, or inches squared, also known as square inches. So now I have pi r squared for the larger circle, pi radius squared, so pi times 2.25. This is in square inches. Whatever that answer is, we're cutting it in half. Okay, so right now I can do that. I can say, what is that cut in half? 2.25 times 0.5. Maybe that makes it easier for you in your calculator. I'll try to make that easier. That's what half is. It's a semicircle, so this is because it's semi, not a full circle. Okay, half of a circle. If you cut that in half, divide it by 2, or multiply by 0.5, we get 1.125. So now here's what I have, 1.125 in square inches. That's the result of multiplying those two numbers together, next to pi. This is how many copies of pi we have. So this is technically the area of the large semicircle. But the only problem is it does include this little inside circle here. So we're going to need to subtract that out. Now you are welcome at this point to do the multiplication and figure out approximately what that is. Let's see what that is. Times the pi button in my calculator. That's approximately 3.534291735288517. So it continues on, right? But what we're interested in is not that necessarily right now. We want to keep the exact answer until the very end. Just keep in mind that's technically approximately what we're dealing with. Okay. Now what we'd like to do is only find the area of the shaded region. So to do that, we're going to need to subtract the smaller region here. So let's take a look at our smaller region. Area of our smaller semicircle. The unshaded one. That's who we would need to be subtracting. So the area of a circle, again, is pi times radius squared. Now, what is the radius of this smaller circle? Well, if it was the full circle, it would look something like this, right? Completely down. It has a diameter, it tells me, of 1.5 inches. So what is its radius if its diameter is 1.5 inches? Well, wouldn't it be half? Like last time, the diameter was 3 inches. So half of that, the radius was 1.5. So if the diameter is 1.5, let's cut that in half. 1.5 divided by 2. What do you get? 0.75? Check it out. 1.5 divided by 2. Yep, you should be getting 0.75 or 0.75 inches. So if you get 0.75 inches is your radius, then the area of the entire circle would be pi r squared, but since I want a semicircle, we're going to cut that in half again because it's a semicircle, not a full circle. So let's go ahead and do this. We're going to take pi times whatever our radius is, square that, take the result, and cut it in half because it's a semicircle. Okay, so let's take a look at what our radius is. We said it already. Our radius here this time, that's right. Our radius this time is just not the full 1.5, it's just this piece here. So that piece there is only 0.75 inches. So 0.75 inches. If I take that in my calculator and I multiply r squared, that's 0.75 times itself. 0.75 squared is 0.5625. 0.5625. Inches times inches is inches squared, or squared inches. So now I have 0.5625 square inches times pi to give me the area of the entire black inner circle. But I only want half of it because notice it's half of a circle. So I multiply that by 0.5 or 1/2, or I divide it by 2. So the exact answer for the smaller semicircle is 0.5625 times half. Cut that in half, multiply by 0.5 or divide by 2. We get 0.28125. 0.28125 when I multiply these two together. 0.28125 square inches, or inches squared, times pi. This is technically the exact. So these two answers, those are called exact answers before you approximate anything. Okay, so we have the exact answers there for the smaller and the larger semicircle areas. But if I want to find the approximate area, again, I can multiply 0.28125 times the pi button in my calculator, or approximately 3.14 if I was using that. So times pi. And now I'm getting 0.88357, 0.8835729, oops, that's an ugly 7, 29338, and it continues on from there, 22129, etc. This is called the approximate answer. These both are approximations. Now here's the danger when you're trying to calculate your answers here. If you were to subtract your approximate answer minus your approximate answer and round too soon, you might be a little bit off. So right now, if I go to my calculator, for example, and I'm trying to answer the question, what is the area of the shaded region? So what is my shaded area? I would need to take my larger minus my smaller, or the shaded minus the unshaded. So in this case, right now, if I was doing that, I would be going to my calculator and typing 3.53, let's say. If I do that, 3.53, if I just round to, like, let's say right here, the nearest hundredth, 3.53 minus let's say 0.88, nearest hundredth again. And I'm getting 2.65. Now this time I'm pretty close. That's actually pretty accurate according to my math lab. So when I do that, I did 3.53 minus 0, I should do it more clear here, sorry, 0.88, and I'm getting roughly 2.65 as my answer, and this is in square inches. That is, I believe, what my math lab would ask for in this question. However, one other thing you could have done is you could have taken your exact answers here. The exact answer for the larger one was 1.125 pi, and the smaller one was 0.28125. 0.8125 pi. Notice that those are both pi's, so you could technically subtract 1.125, let me do that here, 1.125 minus 0.28125, 0.28125, and it leaves me with 0.84375 copies of pi. If I multiply that by pi, I get the same thing, approximately 2.65. So either way, in this problem, if you did the approximate minus the approximate or the exact minus the exact, being careful to do the 1.125 minus the 0.28125, and that's how many copies of pi you had, then when you multiply by the pi button, you'll get your answer. So either way, you can get the correct answer here. The shaded region, which is the semicircle, the larger semicircle minus the smaller semicircle, turns out to be approximately 2.65 square inches, or inches squared. Well, I hope that helped. And if you have any further questions, feel free to email me, and I'd be happy to help. Otherwise, happy practicing. And remember, math is not a spectator sport. See you next time.